right. So we did 3 examples. Do you remember doing these? Okay. Now, this is where we stopped. What did you all discover about the area of a parallelogram formula? What is it? It is base times height. What's the relationship between any base and height, Kayla? Excellent. What's the relationship between any base and height, Travis? Perpendicular. All right. So, I think I'm going to go to a new page. Let me back up one. And let me do this. We have rectangles, correct? Because you have to know these. The EOC is not going to give you these. We have parallelograms. That's another rectangle. I want a parallelogram. Okay, we have parallelograms, and we have squares. And what I want to impress upon you all is that the area formula for all 3 of these is base times height. So if you want to get out your foldable, you will be able to hear on the, it'll be very loud here. Sorry about that. All right. So if you have your foldable out from your parallelograms, okay, on your parallelogram flap, what are you going to write? Area equals base times height. On the rectangle flap, what are you going to write? Area equals base times height. On your square flap, what are you going to write? Area equals base times height. And I suppose that's true for a rhombus also, but a rhombus has another way that you can do it. All right. So, if you look at this picture, what is the base and what is the height? 9 is the base. Okay, why didn't you choose 5? What's wrong with 5? How do you know? The relationship between any base and height is what? Perpendicular. This is where the perpendicular relationship is. Is this side 9 and that side 9? So if we were going to find the area of this parallelogram, we'd say 9 times 4.2 or 37.8. Who's got a calculator to check my computations? Okay, so now I wrote your test, but I haven't finalized your test because I really need to see. I really would like to give you problems like this. Okay, so this is perpendicular. What's the base? 10. Okay, what's the height? We do not know, but that is the height right there. So what are you going to work with? 30, 60, 90. Opposite 30 is? Opposite 60 is? Opposite 90 is? 2x. So what's our equation? 2x equals 4. What does x equal? So if this is 2, how do I find the area now? 10 times 2, which is 20. Again, your homework is A44. Not 8:45. So at this point in time, I've got 30, 60, 90, 45, 45, 90 triangles in your figures to find missing pieces. SAT, ACT. 30, 60, 90, 45, 45, 90. Big time. All right. Now, I've told you that this is 6. I've told you this is 2. This is 5. What is the base? 8. How did you get 8? Okay, this whole side is 8. Okay, what's the height? Is it 6? Is it 2? Is it 5? What is it? We don't know. But we do know it's here. How am I going to find that length? Pythagorean theorem. So if we let this, we'll let that be h for height. So I'm going to say h squared plus what? Is equal to? So you'll have h squared plus 4 equals h squared equals h is equal to plus minus square root of what? Okay, what are the factors of 21? Are there factors of 2 factors of anything? So if this is the square root of 21, what's this area? What's the base? What's the height? So what is my answer? What's my base? 10. What's my height? Why don't we know? It's the perpendicular. It is not that. What kind of triangle do we have? What if I hadn't drawn that little dotted line in? What if I had not drawn it in? What would you have had to do? Exactly. You would have had to draw it in. All right, so what's opposite 45? X. What's opposite this 45? What's the hypotenuse? What is your equation? X square root of 2 is equal to 4 square root of 2. So what does x equal? Because you divided by square root of 2. So this is 4. So how are we going to find this area? Base times height, or 40. What am I requiring you to remember? 30, 60, 90, 45, 45, 90 in Pythagorean theorem. Why? Why am I doing this? Because it's on the EOC. Will the EOC have a lot of problems where you just have to know one thing, or it's going to be problems where you have to use lots of things? It's going to be lots of things. It won't be a 45, 45, 90 in isolation. It'll be a 45, 45, 90 with relation to, let's say, area. Yes? You could, if I ask for exact answers. This could be on the non-calculator portion. And I will let you know. I will say use exact answers. All right? Exact answers means you cannot give me a decimal approximation for square root of 2. Square roots have to stay square roots. Okay, so we have to find the area of each parallelogram. Let's do this one. Oh, wait a minute. That's moving ahead. All right, so the area formula for a triangle is it's base times height divided by 2, or 1/2 base times height. That's a times. Now, the only reason why I prefer not to divide by 2 if you have nice numbers is great. But if some of these are fractions, it's easier to use 1/2. Now, when I give you these problems, I will give you every single side of the triangle and 6, because what am I trying to determine if you know? The base and the height from all the others. What's the relationship between any base and height, Samantha? Perpendicular. All right, so Caitlin, in this figure, what's my base and what's my height? 12 and 6. We're going to take half of base times height. So that means we can do half of 12 times 6. Or we can say 72 divided by 2 is 36. Do you understand how the half came into play? What is a triangle? It's half of a square or a rectangle, or it could be a parallelogram. So with that said, I want to go back to this area right here. Let's look at this figure. If I were to drop down a perpendicular, is the center part easy to find its area? It's going to be 3 times 3 or what? 9. Now what I want you to focus on is look at this. Maybe I should make it a little bit smaller. Look at, is this a rectangle? What is the area of this rectangle? And what did that diagonal do to it? Split it in half, so this is what? 1.5. If we look at this, what is this rectangle? 6. What happened? Split it in half, so this is what? 3. So that's one way that you can look at those pieces. Here's our parallelogram. Do we even need to subdivide it? What's my height? 3. What's my base? 4. That relationship is perpendicular. I don't know. I put these in here, though. All right.
Wait, what's on the bottom? Wait, what are you doing?
This one?
Yeah.
Okay. So if we wanted to look at this one, what could we do? Okay, we can make a triangle here. I would say, I thought you said cut the top off and make a triangle.
There you go. Go right. 1 square. Down. 1. There you go.
Oh, the problem there is what's my perpendicular? You with me? What if I were to stop there? Do I have a right triangle? Right here. Do I? Okay. What if I were to do this? Do I have a perpendicular? Right here? This one? Okay, so is that blue line perpendicular to this one? Is this line perpendicular to that one? All right. So what if I were then to take,
What are you doing?
are those all squares? Okay. So do you see how that, so I would have to separate this here.
Or you could just draw a line. So you see where you did that little, like,
Mm-hmm.
right there? Just draw a line all the way, go up 1 square. Oh. There you go, just like make a line all the way through. And that makes a rectangle in the middle. And then if you move all those lines out of it, there's the clear house to see.
But that's not a triangle anymore. See, that's,
Move that right there.
move what?
That arrow that you just said was making it not a triangle. What are you doing?
Well, but do you agree this is not a triangle?
It is if you move the arrow.
You just,
That arrow. On the left one. Left. Wrong way to describe. Nope. Wrong arrow again.
wait a minute, that's as far left as I can go.
The one hanging down.
Alright, now
Just shorten that.
Yeah, just shorten it. There you go. See, there's a clear altitude.
Oh.
The corner. Oh my gosh, that was big. The one all the way at the right still looks like a clear corner.
Oh. Yeah, that's not clear corner.
That's the problem also with the other place.
There is if you split it in half.
No, it's not. Because the line goes through like the middle of the square.
Yeah, see that's a problem.
That's how the,
Now, what about that?
that works. Yeah.
Now, does that work?
Yeah.
Okay, so there's some thinking to be done. Well, I'm missing one line, correct? Oh, no, wait a minute. Don't I need to put this here and shorten it? Okay. There are. So 1, 2, 3, 4. Do you agree that's 5? Okay. So what is this? 2, 4, 6, 8 split in half? 4. This is 2 by 3 split in half? 3. This is 1 by 2 split in half? This is a 1 by 3 split in half? This is a 2 by 2 split in half? And this is a 1 by 2 split in half?
What are you talking about?
This one down here.
We already did that before.
Oh, just kidding. Sorry. All right, so we got 5 and 4 is 9, 10, 11, 12, 13, 14, 15, 16.5. That was a hard one. Okay.
Can you go back to
That one?
the
So the one we just did, when it was go from like one angle to make like how you find the number of triangles in like an octagon or something like that, I know.
An octagon?
No, like on the investigation we had to draw like a line that's like one angle.
Right, right.
We have done that for that or no?
Possibly, but then you have to be able to figure out. Yes.
you go like
Yes.
there's the area.
That one?
No.
Oh, that one.
Yeah.
Okay. So now we're going to do more triangles. So I just wanted to show you how that rectangle deal on the coordinate plane can sometimes help you find the area. Sometimes you might have to just do base times height on the coordinate plane. Okay, so now let's look at this one. What's the base? Area is going to equal base times height divided by 2. Okay, this is the triangle right here. The base must be a side of the triangle. So one of those 3 sides is the base. Okay, and the question is, where's the perpendicular? So you follow that perpendicular over. What is the base? 13. What is the height? 5.3. And then we say over 2. What's 13 times 5.3? Okay, he's guessing 66.5. That's more than I've done. $68.9? You were close. All right. Looking at this triangle, where's the base and where's the height? Where's the base and height on this triangle?
6.
Why are the base and height 8 and 6? Because of the perpendicular. So we'll say area is equal to 8 times 6 divided by 2, which is 48 divided by 2, which is 24. I have no clue. I didn't look at the homework. If someone has a book, they could tell me what's on the homework. What do we have triangles and parallelograms?
Yeah.
No trapezoids?
Yeah, there's no trapezoid.
Okay. Okay. And then the next thing's a trapezoid. All right. So, what do you think you'd have to do on this one? Oh, I gave you everything. Area equals 1/2 base times height. Why did you choose 7 and 14? Because that's where the perpendicular is. So this is going to be 49 when it's said and done. All right, Caitlin, what's your base and height on number 2? Okay, so your 11 and your 4.7 are the ones that we're going to use. So we're going to say area equals 1/2 11 times 4.7. What's 11 times 4.7? What is it? Divided by 2. So I have been told that this is all we have to do. That trapezoids are tomorrow. But let's look at this one because it's a rectangle. I want you to find the area and perimeter of rectangle RECT. Okay? Can someone name a base using 2 letters? CT. Can someone name a height using 2 letters? EC. In order to find the length of those 2 segments, what are you going to have to do? I heard it. Distance formula. So let's find the distance of EC. It's going to be the square root of something. Then we're going to find the distance of CT, and it's going to be the square root of something. What do I need before I do this, though? Yeah, this is the origin. We went 1, 2, 3, 4 to the left, and we went up 1. We went 1, 2, 3, 3 to the left, and down 2. 3 left, down 2. Here we went 1, 2, 3 right, and up 0. So, McKenna, will you get us started on this EC and the distance formula? Okay. -2 minus 1 squared plus 4 squared. So that's going to be 1 squared, that's -3, plus -3 squared is the square root of 1 plus 9, or square root of what? If this is the square root of 10, what is this? Square root of 10. All right, so CT. Let's see, Travis, help us out on this one. Distance formula. Give me 1x. -3 minus 3. Okay, and that'll be plus negative. Okay, over here. Okay, so because you started with -3, let's stay with -2 first, and then we subtract 0. Because it's being squared, it wouldn't have been a big deal here, but if it were slope, it would have been. Okay? So now we're going to have, this is square root of -6 squared plus -2 squared, which is the square root of 36 plus 4, which is the square root of 40. What are the factors that multiply to give me 40, Leslie? All right. What?
The first one, why did you start with that x instead of y's?
Because this formula is x2 take away x1 squared.
That is y squared.
It doesn't really matter who you start with because they're being added. Okay? All right, what are the factors of 10, Hope?
5,
And 4?
4,
What are the factors?
5,
Okay, what was multiplied by itself? So that's 2 square roots of 10. So this is 2 square root of 10. What is this side? Right, what's 5 times 2? Okay, so now, how do we get perimeter? You add all the sides. How many sides are there? So we say, we're starting here, square root of 10, let's go clockwise, plus what? 2 square roots of 10 plus what? Square root of 10 plus what? 2 square roots of 10. Did I add them all? That's a 1. That's a 1. How many square roots of 10 do we have? 1 plus 2 is 3 plus 1. 4 plus 2, 6. That's the perimeter. Now, how do we find area? We multiply. So what are we going to multiply to find our area? 2 times square root of 10 times square root of 10. Why don't we need to divide this by 2? It's a rectangle, not a. What's square root of 10 times square root of 10? Just 10. It's square root of 100, which is what? 10. So this is going to be 20. Okay, is this coordinate geometry going away? No, it is not going away. Now there's a parallelogram. And we're going to call it a day at this, because I don't know. Did you have coordinate geometry? Did you have anything where you had to do distance formula?
Yeah.
Okay. So, did you all finish the warm-ups? If you finish the warm-ups, what I can do is I can put the book under the dot camera and you can get started on your homework. Would you like to do that? They're back up. Warm-ups are back up. How do you do number 2? I want you to use trig, so you're going to focus on a right triangle, which is right here. With respect, where's the hypotenuse? 40 is the hypotenuse. With respect to 30, what is RS? Opposite or adjacent? Adjacent. With respect to 30, what's SU? Opposite. We want TU, so that means we need SU. So you've got to work with opposite, and you've got to work with what you've been given. Which trig function involves opposite and hypotenuse? So you're going to say sine what? Sine 30 equals what's your ratio? X, or opposite over 40, and you go from there. Now, once you get SU, that's going to be SU. What are you going to do to get TU? Multiply it by 2. That's very similar to what you're going to be doing in your Unit 6 project. But what is due on Thursday? Unit 5, which involves the barn quilt. Yes? Yeah, we're just doing 1 and 2. Tomorrow is 3. 3 will take as much work as 1 and 2 did today.
When you use like 30, 60, like stuff, is it always gonna go with the same answer? Like, if you get
If you multiply by the square root and get a decimal, yes.
do you even have project last grade? At 3? How do you go better?
We had a bunch of them all right in a row.
Problem, remember?
Oh,